Hello, everyone, and welcome to another Into the Terminal. Today, we're going to be talking about Secure Shell, or SSH. Nate, why don't we jump on into the terminal?
Yeah. Jump right on in there. All right. So we're going to go over some complete basics. I mean, if you've ever touched a Linux box in the past, I don't know, 20 years, you've probably touched SSH if you've connected to it remotely to do any kind of administration. But we like to start with the basics in the critical path. So what we're going to do here is I've got a RHEL client and a RHEL server. They're both RHEL 9. What I'm going to do is connect from the client to the server, simply enough, using SSH. Now, this is pretty simple. Command is just SSH. And then there's a couple different syntaxes you could use to get the same thing done. But the one I like to use is you use the username you're going to connect with. In this case, the username is RHEL. And then @ says, what server am I connecting to? And in this case, I have a host name set up in my etc host file, which will connect me to the server. And the server's name is also RHEL. So, that looks really cryptic there because it's just RHEL @ RHEL. But imagine RHEL would be like Nate, and the second RHEL would be, server.example.com. Okay. Now it's going to ask you to accept the fingerprint, the authenticity of the server you're connecting to. Now, we're going to talk a little more about this in the deeper dive, but this is basically the key that identifies the server I'm connecting to. And it'll use this later to identify that server again the next time you go to connect to it. So we're going to say, yep.
You only have to accept that the first time you connect.
True. Right. Unless it changes. But again, we're going to talk about that later. And then you'll see it's asking me for a password. We're going to talk about different ways to authenticate later as well. This is kind of like the basic out-of-the-box way you're going to find SSH. So in this case, I'm going to put in my super secure password. I'm going to do it again because apparently I can't type. There we go. And now here we are. We're connected to my server. You can see I'm connected as the RHEL user, RHEL @ RHEL, right? I'm going to clear the screen there. And you'll see, look at that. There's a file there, which you might guess is part of my next example. But there you go, just as simple. Now, what I've done here is I've connected to my remote system. This communication is encrypted. Again, we're going to talk about how that works a little bit more in the deeper dive. I can issue commands. I can type private things. I can do all kinds of stuff, and nobody can spy on me unless they've done some really, really cool trickery to be able to spy on my SSH session. So I'm going to log back out of this session. The next thing I'm going to show is you can also move files over the same mechanisms, right? And there's two ways to do that currently on RHEL 9. In fact, on RHEL 8 and 7, and really way back, there's two tools you can use to get that done. There's SCP and SFTP. We're going to talk a little bit about the differences there, especially as it pertains to RHEL 9, because there were some changes that came with RHEL 9. I'm going to show you both just to show you that they're really, really similar on RHEL 9. In fact, you might even call them identical. So the old school way, SCP, and then we're going to use that same format, RHEL @ RHEL, now, and then we're going to specify a path for the file we want to copy, right? So this works very similar to the copy command in Linux, where you do copy and then source and then destination, except in this case, my source is a remote file on this server called RHEL. And I'm going to connect as the user, RHEL, right? Now, the file was called file1. This file's in my home directory. SCP, SFTP, they're both smart enough to know that. They'll use a relative path. If it's somewhere else in the file system, you just specify the absolute path. You can even use some bash shortcuts like tilde and whatnot to denote home directories and things like that. So that's the source. And then destination, we're going to copy it right here. And in fact, I could even specify a file name. I could call it I saw it happen, so I stopped. All right, let's get my command going again here. Let me clear the screen. SCP, RHEL @ RHEL, and then, of course, the source file, file1. And then we can, as I was saying, as I got dropped off, we can actually specify where we want to copy it to. I could call it file2 locally if I wanted to, right? So hit enter. Again, it asks me for RHEL's password. See if I can get it right on the first try this time. There we go. And now we're going to have file 2 here, right? Here it is, which is file 1 on the source. It's now in the destination. It's called file 2. Now, I said there's another tool to get this done. That's called SFTP, right? In RHEL 9, I think they're the exact same tool. I think SCP was deprecated or removed, and SFTP is replacing it, right? So that's a bit. Go ahead.
A tool that's been deprecated, it's the backend transfer mechanism. So SCP, the command still exists. It's just using a transfer mechanism that's identical to SFTP. And
right.
Jump to SFTP, would you mind recalling your SCP command for me?
Sure.
I did want to point out one thing. So Nate mentioned the SCP works like copy, where your source file and your destination file are the two arguments passed. So this invocation, Nate specified his source file was remote. And then it basically contacted that remote machine and pulled the file to his local machine. If you flip-flop that, you can take files from your local machine and push them onto remote machines.
Yeah. In fact, I could swap that for the SFTP example if you'd like. Simple enough. So if I did SFTP.
Ask Nate again.
Curse you, macOS, and your flawed update. Sorry, was that live? That was live. So we're going to SCP file, what did I call it? File 2. And then we're going to specify a remote location, RHEL, at RHEL : and then I don't want to overwrite file 1. So I guess I could just say, if I do it just like that, it'll keep the file name the way it is on the source and place it on the destination. So if I do this, oh, does it not work with SFTP in the same way? It should, shouldn't it? See what happens when you go off script?
Exactly.
Okay, so we're gonna use the other example, which you're gonna see if we just SFTP, just replace SCP with SFTP. It'll take the remote file and place it at a local file. We're gonna call it file 3 this time. And to Scott's suggestion before, if we use SCP, and I know this works, I used to do it all the time. If we take file 2, and you say RHEL at RHEL : and then we'll call it, I don't know, file 4. What this should do is it'll copy the local file up to the destination. Right. This one's working like expected. So I guess there's one of the differences between SFTP and SCP. So, all right. So now you've seen all the ways that you can move files back and forth. Try not to use SFTP to copy a local file to a remote. I had no idea that wouldn't work. There must be a different syntax to make that work, unless I typoed something and didn't realize it. I don't think I did. Yeah. All right, and that's our examples for moving things around. Like I said, super basic. We're going to get a little more deeper in the deeper dive because that's what it's for.
Indeed.
And then Scott's going to drop out of the stream because I've already paid my penance.
In the deeper dive, we're going to be, taking questions from the audience, but also we're going to talk a little bit more about why SCP and or SSH, I should say, a little bit more on how it works. And then we're going to talk about some additional, more advanced features like the ability to do key-based authentication.
Right.
And we'll kind of round out with some server-side configuration changes that you might be interested in, and then also some troubleshooting things. Like I find the same things get asked on Reddit and out on the internet periodically. So we'll talk about what those are and how one can solve them. Don't forget to mash that like and subscribe, and we'll see you in just a moment in the deeper dive.
Yeah.
Nate. So it's Red Hat Week.
It is. It is We Are Red Hat Week, isn't it?
Yeah. So for those of you who don't know, at Red Hat, we have a week every year in October called We Are Red Hat Week, and we just like do things to celebrate being Red Hatters.
Like
And
put
this
a penguin on
actually
my
is
hat.
this is a shirt from We Are Red Hat Week a number of years ago.
That's like total historic right there. Does it have the old logo or the new one? We can't
It
see
does
it.
have Shadow Man on the back.
Oh. Well, don't turn around. Somebody will somebody will report you.
All right. So before we start getting into like how SSH works and some other things, I did want to surface a comment from the audience. If you're a deferred viewer, please feel free to leave us comments on the video, and Nate and
Yeah.
I regularly respond to them. But JSCAR mentioned rsync,
Mm-hmm.
and rsync is another file copy utility. But what's interesting about rsync with this topic is that it too uses SSH as the transfer mechanism for files.
Right.
So you can use rsync as well if that's your preferred copy utility, and it actually uses the SSH connection and encrypted um, tunnel to transfer all your file copies with rsync as well.
Yeah, the nice thing about rsync is there's a lot more flexibility in specifying what you're copying. You can do things recursively. You can do things where it'll actually synchronize the source to the destination. Instead of just copying the files, it'll compare them and say, okay, the destination is different, so let's overwrite it with the source. We can actually then remove stuff on the destination that didn't exist on the source. There's all kinds of options you can get with rsync, and it'll rsync over the same protocols, which is handy.
Yeah. And Thor Carlson asked how to handle it if you're trying to SCP directories that may have subdirectories and like a whole directory tree.
Yep.
And if I remember correctly, the answer is -R to
Yeah,
recurse.
recursive. Just do an SCP recursive. And again, I don't know if the flags are different for SFTP, but I'm sure there's a way to get that done as well.
Yep. All right. So, Nate, what's SSH?
So we touched on this a little bit. SSH is, well, if you go back far enough, we used to manage remote systems using open protocols like Telnet and FTP, which were always a bad idea, but it's what we had at the time, right? And the problem with those utilities is that if you had a bad actor that was able to get anywhere in the stream between your source and your destination, they could sniff those packets and they could reassemble them into whatever your session was and pull out things like sensitive data, such as username, password, and the destination that you were connecting to. Very bad stuff because now they have your username and password and they can go connect to the same system that you were on. So back in the late 90s, I think it was, SSH replaced Telnet with the way in which you would connect to a system. Now, Telnet was still around for a little while, but it was very like discouraged. Um, so you'd have an SSH server that ran on your server, and you would connect to it, and it does this key exchange, and you end up with an encrypted tunnel between the client and the server. And then your entire session, which looks very similar to how it used to in the Telnet days, is now encrypted, so people can't actually read that data. So that's essentially what SSH is. You got anything to add there, Scott?
Just I started using SSH in like 1997,
Something
1996,
like that.
and that's kind of when it started. There have been several machinations of it, the encryption technology used to back SSH. So earlier versions of SSH, like back from the 90s, are not really considered secure anymore because the
Hmm.
cryptography algorithms used there can be essentially captured and the encrypted content can be decrypted. Um, just like DES3 and some other older algorithms.
Yeah. I mean, this is as technology marches forward, encryption has to march forward as well, is really what it comes down to. Because usually encryption, it's not necessarily foolproof. There's always ways to reverse encryption, but it becomes like diminishing returns, right? You don't have a machine fast enough to decrypt on the fly or even decrypt post, right? Because it'll take you years to get through it and decrypt it, and by the time you've decrypted it, the information is useless. But as machines get faster, or as machine architectures change, or as we get GPUs, or there's all this conversation around quantum computing, we'll probably have a lot of changes in encryption when quantum becomes a little more readily available. Encryption algorithms have to change. So the way we do this, so SSH from 20 years ago is no longer secure because we have systems fast enough that they could conceivably decrypt that data or brute force decrypt that data.
All right. So we talked a little bit about SCP and SFTP. There was another question in chat that I answered about it as well. So the SCP command stays around.
Yeah.
The difference should be invisible to users, which is the SFTP transfer backend. It's what's used when we're transferring those files between the two machines on either side of the connection.
Yeah.
So we're not getting rid of SCP. We've simply changed how it transfers files to use the SFTP backend, which is a more secure way of transferring the file itself.
That was what I had meant to say, but I think I said it in the wrong way. So yes, the protocols in the back end are using, and that was because there were some vulnerabilities that were difficult to fix in SCP, and SCP was an older technology anyway. So SFTP is now here to replace it. We have a link in the description, or not in the description yet, but we'll have a link in the notes where we've got a blog about the differences, because there are some very minor differences about shell expansion and whatnot between the two protocols. So those are things you might want to be aware of if you were very dependent on some of the more esoteric use cases for SCP.
All right. So, Nate, how does SSH actually work?
Right. So I don't have a whiteboard, but a quick description is SSH between the client and the server uses a number of different key exchanges to figure out, first of all, you saw that where I had to accept the key when I connected during the critical path. That's because the host has a key that the SSH daemon is using to encrypt traffic. That's called the host key. And then the host key is used to identify the host. And whenever you go to connect to it, your client has to say, okay, what's your key? And it gets the key and it accepts that. And that's the public key of the host, right? And now if that key ever changes, your client will say, something weird's going on here because I remember this host. I remember what its key was, and it's different now. That could mean that someone has intercepted it, or it could mean that something happened on the server where the key had to be regenerated. Sometimes not malicious, sometimes malicious. But the point is, the SSH client will give you a warning and let you know, hey, that's different. You may want to act on this, right?
So I just did a quick run through where I connected to a machine for the first time. It asked me if I wanted to import the host key, which I said yes. And then when I exited that session, what you can see is in the .ssh directory for my user, there's a file called known hosts. And if I do a cat on that, these are the hosts that I've imported the host side keys for. And the idea behind host keys is that you can validate the identity of the machine that you're connecting to. And the reason that it errors out and says when you're SSHing into something and throws an error if that doesn't match is because in theory, someone has taken away the machine you're used to seeing there and put back a machine in its place with its same IP address and host name, which you might not want to connect to and do things on. So it's a prevention or a mechanism to prevent either man-in-the-middle attacks where someone substitutes something in between you and your target host, or that there's been a change in the infrastructure without you knowing that there's been a change in the infrastructure.
Right. And that's where there could be nasty stuff going on.
Yeah. And on the client side, I'm sorry, on the server side, in the SSH directory, these are the host keys that are created. And Nate, when do these host keys get created?
So they get created the first time the daemon starts, as far as I know. I don't think there's any other. You may be able to trigger it otherwise, but when you install the system, it'll generate them. And I was going to mention this after you started talking about the keys. if you build the system and then make it like a golden image that you're going to use to provision other systems, you need to make sure you nuke these keys in the golden image so that the first boot after you deploy something from that golden image, it makes a new key. Otherwise, you're going to have all of your hosts deployed with the same host key. And that, I mean, it's not necessarily bad. It's not going to break anything, but it's bad practice.
Well, it may break things if like keys don't match between different machines that you're connecting to, or they're identical to other machines that you've connected to.
Yeah, the client may complain about that.
Right. All right. And then the other thing to keep in mind is that there's actually two sides to every key. And I see in the chat, Secret asks if we can go to a deep dive of encryption. I don't have a whiteboard today, so we're not going to like do a bunch of conceptual stuff today, but that might be worthwhile in the future.
But now you're in for it because
right.
Scott's going to get that whiteboard next time.
So there's two sides of these asymmetric keys, right? So what is encrypted with one can be decrypted with the other.
Right.
So what happens is when a client connects, they're going to send a piece of data that is encrypted with this machine's public key. And the only thing that can decrypt that data that's been encrypted with the public key is its matching private key, which is not shared inside of this server. And then we're going to put together a response that's encrypted with the private key that's resident on the server and send it to the client. And because the client has the matching public key, they can decrypt the challenge and validate it. And so because both sides were able to transmit a piece of data and get back a response with an update that was expected, encrypting it on either side of that connection tells both machines that we have a valid encrypted connection, that our identities have been established, and that we can then establish an encrypted connection with one another. And we'll see this played out in the key-based authentication that we'll get into in just a for users. Yeah, it's going to be a long day.
It is going to be a long day. I'm going to start joining this stream from like a different computer or something because this is getting frustrating. We identified last week, folks, that there was an update to Mac OS. And since Scott and I are both doing this live stream from Macs, we're both impacted by it, where there are these weird network drops. And that's why we keep dropping out. So it's not us hitting the wrong buttons or something, or our ISPs giving us trouble. It's literally the operating system we're running on. We should be running RHEL, don't you think? RHEL wouldn't do this to us.
Well, yes, however, we don't really have a desktop version of RHEL either. So there's like another can of worms you get opened.
Yeah, no, I agree. I was only a joke. We should be running Fedora then.
I mean, that's not a bad option. All right. So anyway, I mentioned keys just a moment ago. And so I have this regular user on my machine named RHEL, similar to Nate's, and I can SSH to client 1. And that's the first time I've connected there, so I'll import the public key. Oh, did I not make the change over here?
You're trampling my demo from later. Come on.
Changed it on the wrong server. All right, let's try that again. There we go. All right, so now I'm connected to this remote machine and everything's good. But when we talk about things like some of the other capabilities of SSH, for example, you can do it SSH-C and execute a command remotely.
Mm-hmm.
If I sorry, SSH, it's been a minute. Oh, you know what it is? It's just a.
I don't think there's a.
Sorry.
I think just put the command at the end. Yeah.
That's what happens when we go off script.
Yeah.
All right. So when I made that command, it asked me for the password for that SSH connection to the remote machine, and then it ran the command on the remote machine and then displayed the output locally and then closed the connection. Well, if you're trying to do something like a shell script where you're connecting that remote
Remote
machine
machine.
and you're doing several things, or you need to connect several times to collect several pieces of data, having to type in the password over and over and over again can be really annoying.
Or if it's automation, right? Same deal. If that was an Ansible playbook, right? Because Ansible will also carry over SSH. You don't want it to ask for a password every time. If it's automation, it's supposed to be non-interactive. It's supposed to just happen.
Yeah, and so what we can do is instead of using our password is a authentication token to prove my personal identity, my user identity to the remote system. I can do key-based authentication, the same that we kind of did with the validation of the two machines involved in the connection. So in order to do that, we first have to create a personal SSH key. And there's a command called SSH keygen that will generate this public and private pair key. The default is to store it in my home directories.ssh directory, and it uses an RSA formatted key by default. So it says, I want to create a file named ID_RSA. And if you're happy with that, you just hit enter, and then it'll create it. Passphrase. So without a passphrase, it stores the keys unencrypted in your local.ssh directory. With a passphrase, you are basically going to be asked for your passphrase to then unencrypt your key before presenting it to the other machine you're connected to, so it stores the key encrypted locally. All right, and out the other side of this is I now have these two files. The RSA private key, which has been encrypted with that passphrase I put in, and the public key. Now, the other reason you want to use a passphrase is that if someone were to take your private key, if it was unencrypted and did not have a passphrase assigned to it, they could then present that at different machines and authenticate with that credential. So a passphrase is really a two-factor authentication. You have to have the file, this ID RSA private key file, and you need to have the passphrase to unencrypt it and utilize it. So it's recommended that you use a passphrase when working with SSH keys.
Especially if you're talking about like the key on your laptop connecting to your company's like core infrastructure, right? Because if your laptop gets lost or stolen and that drive's not encrypted, now someone has your SSH key. And if you didn't have a password on it, they can use it. All they have to do is figure out what you connect to, what your username is, and they can get all that from the history of that machine, right? From the SSH known hosts, from your bash command line history. Like bad things happen if someone gets that key.
Now, the other side of this is we've created these two keys, one private, one public, is we need to populate the public key on the remote systems we want to interact with. And so we could use SCP and start copying things around, or we can use another included utility called SSH.
Welcome back, Scott.
Yeah, you can use this other utility called SSH copy ID. And then you tell it what remote host you want to copy it to.
Did it drop you from the machine you were doing the test on? I think it did.
It did.
Totally messed you up. It's all messed up.
Oh, hold on.
So these public keys are text, by the way, folks. So if you absolutely had to, you can like copy it to your clipboard and paste it in the right place on the server. Or you can use SSH copy ID, or you can SCP or SFTP the file over and then put it in the right file. There's lots of ways to get this done. But SSH copy ID, or if you had automation, right? If you had some sort of automation set up and you're creating users that way, it can just like echo the public key into the right place. Lots of ways to get this done. But SSH copy ID is a great way to do it in this context.
Yeah. And so the other place where you'll see keys a lot is like if you work with cloud systems, you'll be asked to provide your key so that you can SSH into the cloud system. And there's usually like a just text box that you
Yep.
copy and paste into.
It's worse for you today, Scott, than it is for me.
So we could do something like the ID RSA pub. We would take this text and just copy and paste it into that box when
Right.
someone asks me what my public SSH key is. All right.
And
So
more advanced configurations would be like if you had an LDAP directory that you have your users stored in, you can even use that as the source for these keys, right? IDM is a great place for that. You can even do it with Active Directory. So lots of cool ways to get this done.
So when I used that SSH copy ID command, notice it went over and said, okay, we've added the key to the remote system, and now you can try SSHing. So let's SSH client 1. It's asking me for the passphrase so it can unencrypt and use the private key that's stored locally as my authentication mechanism. So I put in the passphrase, and then it does a key exchange or an exchange of data that similar to the host key, where the remote machine will encrypt a piece of data with the public side of the key. I can then decrypt that with the private side of the key, make a change to it, encrypt it back, and send it back to validate my identity with that remote box. And the SSH copy ID, what it was really doing was adding that public key to this file in my user directory in the remote machine called authorized keys. And if I just cat it, right, that's the same thing that we saw earlier as the content of my ID RSA pub file. So it just takes that, sends it over to the remote machine, and adds it to an existing authorized keys file on my behalf. All right. But Nate, we mentioned automation.
Yeah. Yeah. So
And
basically, what you've done is you've moved the password from the server asking you for a password to the key requiring a password. So, Scott,
right,
how are we any better now?
if I SSH again, it keeps asking me for this passphrase, and exactly
Right.
like any better than before. All right,
And
so
there's been some chat about this. So, we're about to answer your questions. You guys are predicting the future again.
there's a utility on the machines called SSH Agent. An SSH Agent will allow you to add a key to a in-memory warehouse of SSH keys. So let me go ahead and start it up. And then I need to use these to set some local variables in my shell. And basically, it's like this is the SSH agent process ID. This is the socket that we transfer data to and from the SSH agent process on my machine. So these are variables that get set in my user environment. All right, and then I'm going to do an SSH add. And it's looking at my key, and it's taking my private key and adding it to this warehouse of data in the local machine's memory. And what's going to happen is when I SSH to the remote machine again, instead of me being asked for my passphrase, SSH agent is going to intercept that request and provide it on my behalf. So when I SSH to client 1, it just happens.
No more password.
For anything, it just passed me through. And that's really the SSH agent intercepting the passphrase request and supplying it on my behalf so that we can then do the key exchange and data exchange and identity validation. What's really cool about this is that it is in memory. So if I close this shell, what I've put into the SSH agent vanishes. So every time I create a session, I will have to add my passphrase again into the SSH agent. This is also something that happens by default on many graphical environments. So if you've SSH to a machine using a graphical utility, it may have popped up a box that said, please provide your passphrase, and like a
Yep.
graphical utility. And that's the SSH agent operating on your behalf. But what's cool is, remember earlier I connected to this remote machine and ran a command?
Hmm.
Now it just does it. And if I
And once that key authentication is in place and it's unlocked, you can even do like path completion using tab on the remote system, which is insane, right? If you did like, I don't know, if you used SCP and you're looking for a path and you don't quite remember it and you're used to using tab completion when you're on the local machine, that'll work if it has authentication because it can actually connect to the remote system and say, what's that next path? And then auto complete it for you on your local shell, which is the first time I saw that work. I'm like, wow, that's really handy.
Yeah. And just to tie it off, like if I exit this shell and come back in, notice it's asking me again for my passphrase because I closed my session where I had uploaded my passphrase into the agent, which then vacated that information from the agent. And when I created a new shell, I have to re-add my credential into the agent if I want it to persist during this session. So you can just close your session and anything you've loaded in the agent just goes away.
Now, you might be asking, how does that really help me? Because in the automation use case we talked about earlier, you still need this password stored somewhere. Well, in the case of Ansible, for example, there's things called Ansible Vault, or there's a thing called Ansible Vault, or there's lots of other ways that you can integrate third-party tools that use a vault like that with Ansible. And it'll read, you can store that password in in a vault that's encrypted in its own, right? And then it'll pull in the SSH key password from there. Or if all else fails, maybe not the best security, but if you have a sufficiently protected automation server, you could have a key that's not encrypted there. But then just know that if someone gets that key, you're going to have to redo the SSH key authentication on all your systems, and that's not fun.
Yeah, and so I noticed that a data ready said, "Can I use the passphrase programmatically so I don't have to provide it every time?" SSH agent is the way to do that. I saw a couple
Yeah,
people like, you don't want to put it in your shell script because then you're providing your passphrase in plain
yeah,
text, storing it somewhere. So agent, or if you're using something like Ansible, using the Ansible Vault, are the ways that you securely hold on to this data and pass it on your behalf as you're using SSH connections.
yeah. I've never tried. Is there a way to like seed SSH agent with a stored password somehow? I've never tried that.
I've never looked at it either.
Yeah, I wonder if there's a way to get it done that way. But again, right, you're always going to come down to if there's a password stored, then there's a chance someone can get the stored password. So if you're putting it in a shell script, if you're putting it even in a vault, then you got to worry about how the vault is. Like security, there's always a layer of inconvenience that comes with security. And sometimes you just have to find the least inconvenient way to interact with it.
Yeah, and, the um, product manager for security at Red Hat used to always say something like, "Security is great, but it's always a trade-off between more secure system or system usability." So you always have that trade-off. You can make a really secure system that's impossible to use. So you always have to consider uh, enhancing your security and make your posture better, but without doing it at the cost of usability and making it so that no one actually wants to use your service or capability.
Yeah. Yeah, I always used to come to like when you came to the end of the path and the person you're working with those is always like, but it's still inconvenient. Sometimes the answer is security is sometimes inconvenient. It's like it's really inconvenient to have to unlock my front door when I get home after I've been away all day. But it's a lot, that inconvenience is worth it so that nobody walked into your house during the day and stole your television, right?
Yeah. So changing gears a little bit, Nate, why don't we talk about some SSH server-side things?
Sure, sure. So we've been talking a whole bunch about key-based authentication and password-based authentication. There's a couple things I like to do to the SSH daemon, which helps improve the security of your RHEL system. And I think some of these have actually become defaults in RHEL 9. I'd have to go look at a base deployment of RHEL 9 again to be certain. But let me jump back into my terminal, and we can look at the SSH configuration on my system. So if we go vim etc sshd hd underscore config. Now there's also an SSH client config that lives here where you can configure stuff on the SSH client. We're not really going to touch that today, but just know that it's there if there's any client side stuff you want to configure. But this is the SSH server configuration. And you'll notice we're already at the line where it says password authentication, yes. Now this is on my machine around line number 65. I don't know if that's going to be the same on a base RHEL deployment, because I know we changed some of these configurations on these labs when we deploy them. You can see currently it says password authentication, yes. Now, when I'm in a case where I'm managing servers and I control the deployment of the servers, I will pre-populate my administrative users and their SSH keys. Or if you're in a situation where you've got a centrally managed user domain, you can populate those keys and access at that level, right? So normally what I would do is out of the box, I turn password authentication off, right? Now, let me show you how that works. Well, here, you've seen key authentication work, so I'm not even going to bother setting that up. I'm going to go and turn password authentication to no. Okay. And then we're going to reload the SSH daemon. No, systemctl. Only if you don't misspell reload. Okay. Now, the cool thing is when you reload that daemon or even restart that daemon, existing sessions don't die. I found that out one day. I was managing a remote server. I had to make a change. I didn't even think about it. I just reloaded SSH. And right as I hit enter, I panicked. And then it came right back. Like it never dropped me. I thought that was amazing. I don't know how it manages that, but it doesn't kill connections when it reloads. So anyway, so now I'm back on the client. Remember before we were able to SSH in and type in a password. I haven't set a key up, and I don't think there's one out of the box. Oh. So if I SSH to RHEL at RHEL again, it should reject me. It doesn't even say, hey, what's your password? Or can you help me out here? No, it's just no, you can't. You cannot do that. If I go in as root, and this will make sense in a moment when I show you my next task, there's already a key exchanged for root, right? So here I am as root at RHEL, where I was root on client 1, because there's already a key set up. So that shows you, yes, key authentication is still working. Password authentication is turned off. Now, the reason I like to do that is because go to your favorite cloud provider and spin up a new instance, and then just watch the logs. Within possibly seconds, usually minutes, maybe hours, you'll start seeing brute force attacks against the EC2 user or whatever the cloud user is for that particular cloud. People trying to guess the password. If you turn off password authentication, those will still happen. They'll still try, but they won't get anywhere because SSHD is literally saying, no, I don't take passwords. You cannot brute force an account because you can't give it a password, right? So the other thing I like to do in a similar, for similar reasons, is I like to also tell SSHD that the root account is not allowed to be connected with. So you see permit root login is right here, and it's set to yes. You saw I connected as root just a minute ago, but if we delete this and set it to no, and then we do a reload on SSHD, go back over to my client. If I try to connect as root at RHEL now, it should reject me, but it didn't. Why didn't it? Was there another See, I didn't test this because I assumed it was going to work, but sometimes it's in the SSHD config more than once if you use automation to configure this stuff. So let's try it again. Ah, there it is. See, it's there twice. That's whoever made these systems, Scott, terrible administration. Let me check, see if it's there a third time. No, it's not. So let's reload it again, and this time it should not let me connect as root. All right, so I'm root at client 1. I'm going to SSH to root at RHEL, and there you go. Permission denied. It says, no, I don't care. I've got your key. I'm not asking you for a password because I was told not to, but I'm still not going to let you in because you're root, and I've been told root can't connect. Why would I do that? 1, because you shouldn't be SSHing to your systems as root. Bad admin. And 2, because the bad guys are going to try to SSH to your system as root, because every Linux system on the freaking planet has a root account. So that's their first attack vector is, can I get into root? Because if I can get into root, because if someone said a bad password for root and I get into root, I've got your system, right? So I just say, no, you can't connect to root. Root's mine. In fact, root's not even mine. I use sudo for everything. Root is like super protected, off in a corner, break glass if you need to use this account. Okay, I'll get off my soapbox now.
So a couple of like things to mention. So not allowing password-based SSHs is the default for RHEL 9. So key-based authentication is the default. And the other thing is the allowing root or not is an install time question. The default is root will not be able to authenticate. And when you're going through the installer, there's a little checkbox that says, would you like to enable root access to the machine? And if you check the box, you're saying permit root yes in your SSH configuration. If you don't make any changes, the default will be that root is not allowed to log into the system for RHEL now and later.
Yep.
All right. I have my own preference of SSHD changes. So let's throw in my system here, and I'm going to go in to etc SSHD or SSH SSHD config. The thing I like doing is changing ports. So everyone knows the default port for SSH is port 22. Oh, and you have to add it to your SE Linux config.
Ah.
Yep.
Now you got to remember how to do that, Scott.
Exactly.
It's not in your notes, is it?
It is not.
Just turn that off. It'll be fine. So while Scott's looking at that, I'll just throw in a little bit of commentary. Yes, this is a way to effectively hide SSH from attackers. So that use case where I told you about, where you spin up a new cloud instance and within seconds people are starting to brute force SSH, this will at least temporarily limit or block that. So if you've got people that are just blindly trying to connect to port 22 and they don't have any intelligence at all in their attacks, the hackers cut me off, Scott. They don't want me to share the information. Anyway, they won't be able to find your SSH daemon because you've moved it to a new port. Now, I say temporarily because a simple port scan with any sort of intelligence behind it will be able to find SSH. So unless you're doing something, I've heard of like crazy situations where they set up what's called knock ports, where you have to like connect to a series of ports and then SSH opens. That I've never been able to configure it, but it sounds amazing.
Are you talking about knocking?
Yeah, port knocking. It sounds like a really cool way to hide SSH in a way that people are not going to be able to get to it. But if you're not going to go that far off the deep end, simply moving it to a new port can be a certain layer of security. Security. Okay. Security, I see Rick saying in the chat. Yes, that's exactly what this is. It's like the checkbox in MS SQL Server that says hide SQL Server that just adds 1,000 to the port. People know where it moves to. It just makes them slow down for half a second.
Well, but Nate, you were just talking about how when you start up a machine fresh, what you'll notice in the
Yeah.
log are like thousands upon thousands every day of people trying to brute force SSH attack your machine.
Right.
And the reason they do that is because they just like run scripts that SSH to your
Yeah.
machine.
Yeah.
And
Most of those are just automated things. There's no person behind that. Well, there's a person behind it, but there's nobody controlling it. It's just like things that run that are en masse, always checking port 22. So yes, if you moved it to port 23, well, that's telnet. Don't put it on 23 because 23 is also getting hit. But if you moved it to something that's a little obscure, then yeah, those scripts will never find SSH because nobody's thinking to look elsewhere.
you mean like port 8122?
There you go, like port 8122.
Yeah. So that's why it's like you can just refuse all traffic because they'll be connecting to a closed port, and you'll almost entirely cut off all of those brute force scripted attacks if you just move your SSH to another port number. The flip side is one, you saw that I had to add the SSH port T type to this new target port so that SSH will allow the SE Linux will allow the SSH daemon to bind to this non-standard port. The other thing is on the client side, you also have to make a couple changes. So over here on my client, if I want to SSH now, I need to tell it that I need to code to port 8122.
And the syntax you might be used to where you just add a colon to the end of the host name does not work with the SSH client. At least I don't think it does. You have to do that -p 8122.
Right. But the other thing that I use to like make this a non-issue.
Yeah, that could work as long as all your systems are running on that port.
Yeah,
Set up a bash alias. Yeah.
I did it because I didn't want to be brute force attacked all the time. So there you go.
So I did it everywhere. Yeah.
Right. And so if you've not seen an alias before, it's a bash feature that basically says when I run this command, SSH, really run the command SSH-P 8022. And so all the arguments you would pass to SSH pass through on your alias as well, so that when I use my alias SSH, it really runs SSH with some additional arguments and then whatever else I pass in the command line. But as Nate pointed out, like you need to make this, if you want to make this change, you kind of commit to making this change everywhere. And when you don't, you then have to like use -p to say -p22 to go to somewhere new.
I think there's
Or
a bash shortcut that'll say execute this command without the alias. It's like a backtick. Backtick?
it's
Slash.
backslash.
Backslash. That's what it is. There you go.
Yeah. So
There.
it looks like, right? Backslash in the name says ignore any alias that might exist for this.
Yes.
Run it natively. And you can see that because my machine is bound on port 8122, when I try to connect to port 22, it errors out.
Right.
All right, so that's my favorite change is binding to a non-standard port.
Rick mentions that you can also do this in the SSH client config. You can remember the client config I was talking about earlier when I was talking about the SSHD config. There's an SSH config inside of Etsy. If you set all your clients to set the SSH port to 8122, that'll do the same thing. Thank you, Rick.
Oh, so Nate, we want to talk about some common problems that we see around with
Yeah, but I think our old producer is wringing his hands somewhere because we're almost at an hour. So, yeah, there's some common errors that you can run into with SSH when you're trying to connect to a remote system, even if things are working properly, right? And we talked about that one earlier. And I don't know, Scott, if you had cooked up, we had talked about if you could maybe make a demo of this. The one of them would be if that host key changes on the server. Is that what you're trying to get ready?
Yeah, that's what I was trying to get ready, and I think I did it. We'll see.
Hey.
Whoops.
Oh, see that command line alias that you set up is hurt. There you go. Look at how terrible that error looks. Oh my God. Warning, the remote host identification has changed. It's possible that someone is doing something nasty.
Yeah. And what it's telling us is when we try to do that key-based validation of the remote host,
Right.
that the key that it's presenting to us doesn't match the key that we have stored in our known hosts file. So down here in SSH, the last time we connected to that host, it put
So
its
the cool thing before you do that, it'll even tell you offending ECDSA key is in known hosts :3. That means it's on line 3.
yeah.
So if you're trying to figure out what keys it caring about, because you might have 100 keys in there, it tells you right there which line it is. And if I remember, there's a command line shortcut to Vim that'll skip to that key, just like end with the number 3. I think it goes to that line. I don't remember anymore.
I just use :3 inside of VI.
Yeah.
All
Well,
right.
yeah, that's another way to do it. But so before you just like, oh, delete that key, it must be wrong. Make sure you validated that this key has changed for a valid reason before you just accept that and move on. There's a reason SSH defaults to not letting you connect to it.
Right. So this is pretty common in places that use DHCP as an example,
Yeah.
because the machines may reuse someone else's DHCP address that you had connected to previously. And so now when you try to connect to that IP, it doesn't have the same host key anymore because it's moved on the network.
Yep.
Um, it could be,
Or if a machine was retired and then months later you're building a new machine that shares the IP with that old machine, your client config doesn't update when that old machine was removed, even if you were as studious as possible in cleaning up all the DNS entries and whatever, right? If you connect it to it by IP address, there'll be an entry in there for the IP address, and it'll say that's not the key I remember at this IP address.
man, we have a lot of host keys for this machine.
Oh yeah, so I mean, there's actually several ways that it'll store that in there. That it'll do it by the name, by the IP address, and obviously there was a third one that you just had to clear out.
All right. So once I have all the references to this machine removed from the known host file, and then I connect back, it's like the first time I've ever connected this host again. So it's asking me if I want to import the credentials or the keys for this host. Right. So that works. And then when I come back over here, there are the fingerprint ID and the key ID for the host. Oh, I see. It's 3 different types of keys, 3 different
Oh,
encryption.
that's what it was. Okay.
Yeah.
So
Um,
there was a question in chat. If you're the admin, where do you see that failure in the logs to assist the user with why they can't connect to the server? The error is shown on the client, or that error is shown on the client computer. So yes, the error is pretty obvious on the client end. So if a user contacts you and says, "I'm getting this error," now you know what that error is. You know how to troubleshoot it. Uh, the on the server side, I think it's in the secure log. Will show
no,
you.
the server side won't error because it's starting its key exchange just like it would for every connection. And
Right.
so
What
the
I was
server
going to say was
do.
errors like these will sometimes be in the secure log. That was the end of my sentence. But I do not believe this one will show up in the secure log because you're right. Your client is refusing the connection, not the server. The server didn't say you're invalid. The client said, no, no, that's the wrong key, and it'll drop.
All right. Um, the other or another really common error is on your key, on your individual key. So let me go back to my
There goes Scott again. Welcome back.
thank you. Let me break this in a way that we can then see.
There was some clarification in the chat. There is an error in the varlog secure that indicates a key exchange mismatch. It shows up as a libcrypto error, which might be misleading. Although if you think about it, it is exactly a libcrypto error.
All right. So another common one that I see is someone is SSHing somewhere. Whoops, hold on.
You have the wrong broken there.
No, I removed the known hosts for my root user, but did not remove the known hosts for my regular person. All right, let's try this one more time. Yes. This is the other one.
This is a common one.
Yeah. And in fact, this is why earlier in the episode I used
something.
I used SSH copy ID when I was taking that public key and moving it around to the target hosts I wanted to use. If you use copy or SCP, it'll often put the file in place like you expect, but it gets the default file permissions, which are like 664 or 644. And
Right.
for your private key and for your authorized keys file on the remote machine, what we really want in .sh, this file needs to be permissioned 600. Right, so that was what it was complaining about with that gnarly looking error message, was that I had the wrong permissions on that file. And now that I fixed it, when I go and connect to the remote machine again, it works fine. The other place where that's important, notice on the remote machine, this authorized keys is also permissioned 600. And so for some reason it was 644 or 664, it would also give you an error about not having the right permissions on it.
Right.
All right. Last thing we want to cover, and then we'll hit comments and questions in the chat. I've also seen more recently people complaining that their key-based authentication is broken, where they can SSH to RHEL 7 machines, but they can't SSH to RHEL 8 machines or RHEL 9 machines. And likely the cause there is that your SSH key is the wrong algorithm. So on RHEL 8 and 9, we create RSA keys by default. A bajillion years ago, when you did an SSH keygen, it would create a DSA key by default. And on RHEL 8 and 9, DSA keys are no longer acceptable for key-based authentication. And so if you've taken your RHEL 7 generated DSA key and you've put it on your RHEL 8 machine or your RHEL 9 machine, it won't help you, because RHEL 8 and 9 don't accept that algorithm or that cipher for keys.
Right.
So to that, you'll need to regenerate your key as an RSA key to then continue to use it. All right. So questions and comments from the audience. Anything good, Nate?
I haven't noted any. I do want to correct. I'm not sure now if that error that I saw in the chat was referring to the key mismatch or not. It could have been someone asking a question about, but I skimmed over it. So I wanted to just correct myself there. I don't know if that's what that says in the varlog secure, if you've got a key mismatch. If there's questions in the chat that you guys think we've missed, please call them out. I think there's been plenty of conversation, and I think everything's been answered. But without a producer that's focused on chat, it's hard to say for certain.
Well, so I saw this some back and forth. I think that was an error message that somebody was experiencing.
Yeah.
And Rick said, hey, or sorry, Josh asked, are you using FIPS? And the user was like, yeah, I am using FIPS. And it looks like that may be the culprit there. FIPS is the Federal Information Processing Standard. and it has a whole bunch of hardening requirements that one has to go through. And so things like ciphers that are permitted is another one of those things.
Right.
So that might be what's going on there. I saw an off-topic question about Leap upgrades. Secret asked if there was Leap automation for upgrading multiple servers. So you can do such a thing. In fact, some of our solution architects and consultants have written, I think it's a plugin. It's like out on Ansible Galaxy or something, so that you could do that. But essentially, the Leap command is scriptable, so you can hit multiple
Yeah.
machines with the same time.
I think there's integration with satellite too, isn't there? Am I
There is.
misremembering here? Yeah.
Satellite will also allow you to Leap upgrade multiple machines at once. I will warn you that you want to be a little bit cautious that you're doing machines that have all kind of the same reassessment report, right? So you don't want to like just upgrade your fleet. You want to like try to upgrade the same type of machines.
Yeah.
So you've gone through their pre-assessment report and validated any problems, remediated what you needed to remediate, because like there's an error that comes in a lot of them about Python version. And so if you don't care about that on one set of machines because you're not doing Python apps, great. But then what happens if you accidentally mix in a machine where you are using Python apps, and you didn't account for that in your pre-analysis when doing a whole pile of boxes at once? There was also a off-topic question about security updates for RHEL 7, and it looks like it was removed. So I can't read that one to address it. But
So just one comment about Leap. Leap's a great tool. Like there was a time if you had asked me would you consider in place upgrading all of your RHEL systems, I would have been like absolutely not. I would rebuild them all. But after seeing Leap run a number of times, it's a really nice tool and it's got a lot of error checking and whatnot before it runs and the pre-upgrade analysis and stuff. But yes, like Scott was saying, don't just blindly run it. Use your best judgment. Like don't don't just it doesn't matter how good an upgrade tool is. You have to be you gotta use some caution.
yeah, and actually there's a uh, asset that we created called Leap Explained, and I'll try and find it. Maybe I'll have to post it in the episode
Yeah.
comments or stuff after the thing. But it's like a really in depth, like, what is an error? What's an inhibitor? What's the like uh, grade of error? Right? There's like a high and a low. What does that mean? And then the author Ricardo da Costa also went through and talked about like some of the common ones that one might see, and then what is that error actually telling you? How would you remediate it? Type thing as well. So I'll put that in the show description in
Yeah.
our
Because
resources.
obviously one of us or both of us needs to work on time management because we're at an hour and 10, Scott.
Fair enough.
I
All
think
right.
it's time to wrap it up.
So don't forget to like and subscribe. If you know someone who would be interested, share the episode with them.
Yeah. Yeah.
Next week we will be back for Into the Terminal. Don't know what that's going to be yet, but we'll be here next week. RHEL
It'll
Presents
be
is,
great. Whatever it is.
of course, RHEL Presents is on hiatus until we find a new co-host for it. And then yeah, I think that's what we have going on in the real world. Next week is Halloween, and if you don't know, Halloween is a very special Red Hat day because the very first release of Red Hat Linux was on October 31st, 1994, known as the Halloween release. And so Halloween is always something that's near and dear to our hearts here at Red Hat.
There were bats on it, if I remember. Bats on the installation media, weren't there? I think I've seen
Yeah,
pictures. I was not into Linux that early on, I'm sorry to say.
and a really weird red top hat as the
Yes.
logo.
Top hat with bats around it.
All right, everyone. Thanks for tuning in today. Hopefully we'll see you next week.
Yeah. Have a great one, folks.